Welcome back to the deep dive. Today, we are pedaling. Well, actually, we're not pedaling at all. We were zooming.
We are definitely zooming.
We are talking about the silent revolution that is, it's currently parked on sidewalks, locks to bike racks, and just weaving through traffic in pretty much every major city on Earth.
The e-bike revolution. It really has changed the texture of urban transport, hasn't it?
It really has. It feels like overnight, the world just decided that bicycles were great, but bicycles that push you up a hill are infinitely better. But here's the thing, and this is why I was so excited to dig into this specific stack of research today.
Yeah.
We see the finished product. We see the sleek frame, the battery pack, the little LCD display.
Right.
But we rarely think about the absolute miracle of engineering required to make the thing actually move.
You're talking about the motor, the hidden bottleneck of the entire industry.
Exactly. The motor. It seems so simple. It spins.
It makes the wheels go round.
Yeah, but according to the case study we are breaking down today, manufacturing these things at the scale the world demands is, well, it's a nightmare.
It is an incredibly difficult physics puzzle.
Yes.
And frankly, the industry just grew faster than the manufacturing technology could keep up with.
Right.
So you have a situation where demand is vertical, but the factories making the hearts of these bikes, the motors, they're just stuck in the past.
And that is the perfect setup for today's deep dive. We are looking at a specific collaboration between an automation powerhouse, DETZO Turnkey, or DNY for short, and a major unnamed e-bike motor manufacturer. And the reason we picked this specific case, even just because of the cool robots, though, there are plenty of those, is because of the numbers.
The numbers are staggering.
Yep.
Just unbelievable.
I honestly thought there was a typo in the briefing documents. We are talking about a factory that was running at a 30% yield rate.
30%.
That means they were failing 70% of the time. And in just 12 months, DNY came in and flipped that to a 99% success rate.
It sounds impossible. I mean, usually in industrial engineering, you fight tooth and nail for a 2% improvement.
Just 2%.
Yeah. To go from 30 to 99 is not just an improvement. It is a resurrection.
So our mission today is to figure out how on earth they did that. How do you take a chaotic, semi-automatic factory that is just bleeding money and turn it into what is now being called Asia's first fully automated e-bike production line?
To really appreciate the solution, though, we have to get our hands dirty with the problem.
Right.
We need to understand why making an electric motor is so deceptively hard.
Okay, break it down for us. Because in my head, a motor is just magnets and copper wire. Why is that so hard to build?
Well, on a whiteboard, it is simple. In reality, it is a mess of tolerances. The core of an electric motor involves winding thick copper wire around a steel core, or stator. Now imagine doing that by hand.
Okay.
You need to pull the wire tight enough so that it's compact and, efficient.
Okay, like winding a fishing reel? Something like that?
A fishing reel that fights back a lot. The wire is thick. If you pull it too tight, you might snap the wire, or, even worse, crush the insulation coating on it. If you strip that insulation even by a microscopic amount, you create a short circuit. The motor might work for 5 minutes, but as soon as it heats up, poof, it fails.
And if you wind it too loose, what happens then?
Then the wire vibrates inside the casing. Vibration creates friction, friction creates heat, and heat kills electronics. So you have this tiny Goldilocks zone of tension you have to hit perfectly thousands of times a day.
And this client, before DNY stepped in, was trying to do this with humans.
They were stuck in what we call a semi-automatic state. I mean, they had machines, sure, but humans were feeding the machines, moving parts between stations, and doing a lot of the delicate finishing work.
So let's paint the picture of this before state, because the stakes were just incredibly high. Who is this client?
They are a dedicated manufacturer of e-bike motors, and they were drowning, absolutely drowning. The market exploded. Everyone wants an e-bike. They had orders for 1.5 million units a year.
1.5 million. That is a massive number.
It is. To hit that, they needed to produce about 350 motors every single day just to keep the lights on. But they were barely hitting 100.
And of those 100, only 30 actually worked. Is that right?
That is the horrifying part.
Yes.
Their yield rate was 30%. Imagine you are baking cookies. You bake 100 cookies, and 70 of them come out burnt or, poisonous. That was their factory floor.
That is insane. How does a business even survive that? You are buying raw materials, copper, steel, magnets, and literally throwing 70% of it in the trash.
Or spending a fortune paying people to sit there and try to fix them. Reworking, they call it. But a reworked motor is never as good as one that was made right the first time.
And I can only imagine the atmosphere on that factory floor was tense.
It had to be. You have 30 workers on the line. They're under immense pressure to work faster to meet that 1.5 million quota. But when you rush manual labor, quality drops even further. It's a death spiral.
And the documents mentioned they had a cycle time of 300 seconds.
5 minutes.
That's 5 minutes to make one motor. When you have a backlog of millions, 5 minutes is just an eternity.
It is.
Plus, there's the labor shortage issue, right? Finding 30 people who are skilled enough to wind motors but willing to do that kind of repetitive factory work is getting harder and harder.
Exactly. So they had the perfect storm. They couldn't hire enough people. The people they had couldn't work fast enough. And the work they were doing was resulting in a 70% failure rate.
An existential crisis.
Totally. If they didn't fix this, they were going to lose their contracts. Period.
Enter DETZO D&Y. Now, this is where the story gets really cool, because usually when a company says we need automation, they just go buy a bunch of robot arms, plug them in, and hope for the best.
Right. The Band-Aid approach. Slap a robot on it.
But D&Y didn't do that.
No. D&Y has a completely different philosophy. They look at whole plant planning.
Whole plant planning. It sounds like architecture.
It basically is. It's industrial architecture. They didn't just look at the winding station. They look at the entire journey of the material.
The whole thing.
From the moment the raw steel enters the building to the moment a finished, tested motor leaves. They mapped out the flow, the floor plan, the logistics, everything.
So they realized the problem wasn't just we need a faster winder. It was the entire flow of this factory is broken.
Exactly. If you just put a fast robot in a bad process, all you do is make bad parts faster.
Right.
D&Y tore it down to the studs. And the key to their success was customization.
Let's dig into that. The notes highlight custom winding modules. Why couldn't they just buy a winder off the shelf? Surely someone sells a machine that winds wire.
They do, of course. But e-bike motors are unique. They're incredibly compact and power dense. The geometry is weird. A standard off-the-shelf winder is designed to be, okay for a lot of different motors, but okay gets you a 30% yield.
Right, okay, is not good enough here.
Not at all. D&Y built winding modules specifically for this client's motor design. Think of it like a tailored suit versus a suit you buy at a department store. The tailored suit fits perfectly. The custom winder lays that copper wire into the slots with perfect tension, perfect alignment every single time.
And because it's a machine, it doesn't get tired at 4:00 p.m. on a Friday.
It doesn't get tired, it doesn't get distracted, and it doesn't have bad days. It just repeats the perfect motion endlessly.
There was another term in the research that stood out to me, jigs and fixtures. It sounds like something from a hardware store, but apparently D&Y spent a lot of time designing these. Why are they so important?
It sounds boring, I know. But jigs are the unsung heroes of automation. A jig is simply the thing that holds the part while the robot works on it.
Like a clamp.
A very, very fancy, very precise clamp. See, a robot is blind, essentially. It's programmed to go to coordinate X, Y, Z, and weld. If the motor is wiggling, or if it's seated 0.5 millimeter to the left, the robot will weld the wrong spot.
And ruin the motor?
Instantly. D&Y designed custom jigs that hold that motor in a death grip, ensuring it is in the exact same position, down to the micron, for every single operation.
This brings up a really interesting point about the relationship between the product and the machine. The notes mention design for manufacturing. D&Y actually helped the client change the design of the motor itself.
This is a crucial insight. True automation isn't about building a robot that can do exactly what a human hand does. Human hands are amazing. They're flexible, adaptable.
Sure.
Robots are rigid. So instead of trying to make the robot more human, you make the product more robot-friendly.
Give me an example of that.
Maybe there was a wire that was hard to tuck in. A human can use their fingernail to push it. A robot can't. So D&Y says, hey, what if we change the shape of this plastic casing just a little bit? Then the robot can slide the wire in easily.
That is smart. It's meeting the machine halfway.
Exactly. It's a negotiation between product design and process engineering. And that's why D&Y is so successful. They don't just sell robots, they consult on the product itself.
So they have the plan, they have the custom hardware. Now we enter phase 2, the high-tech integration, the sci-fi stuff, the brains and the eyes.
This is where we move from mechanical engineering to digital intelligence. Let's talk about the eyes first, AOI.
Automated optical inspection.
Right. Now, in the old semi-automatic line, how did they check for quality?
I assume a guy named Dave picked up the motor, looked at it, and said, yeah, it looks good.
Pretty much. Visual inspection. But human eyes are terrible at this. We get tired. we glaze over. If you look at 500 motors a day, by number 400, they all look the same. You miss hairline cracks. You miss tiny bubbles in the weld.
And AOI doesn't miss those.
AOI uses high-resolution cameras and advanced algorithms to inspect every single millimeter of the product. It checks the weld seam, the wire insulation, the connector pins. It never blinks. It never compromises.
So that massive jump to 99% yield isn't just because the machines are making fewer mistakes. It's because the inspection is catching things instantly.
It catches defects before more value is added to the part. In the old way, you might finish the whole motor, assemble it, and then find out the very first step was wrong. AOI catches it at step 1.
That must save a fortune in materials alone.
It does. But the real game changer for me, as an analyst, is the brains, the MES.
Manufacturing Execution System. I always think of this as the manager of the robots.
It's the central nervous system.
Right.
Before, data was probably on a clipboard, maybe a spreadsheet if they were lucky.
Right.
Now, every single motor has a digital twin.
A digital twin. Explain what that means.
It means every physical motor has a corresponding digital file that tracks its entire life. The system knows exactly what time it was wound. It knows the tension on the wire during the winding. It knows the temperature of the welding tip. It knows the voltage result of the final test.
So it's totally traceable.
Completely. If a customer returns a bite 2 years from now because the motor failed, the manufacturer can scan the serial number and look up exactly what happened on the line that day. They might see, oh, look, the tension on the winder drifted by 1%.
And I assume this helps with optimization, too.
Hugely. You move from reactive fixing, waiting for something to break, to predictive optimization. You can see trends in the data. Hey, station 4 is running a little hot. Let's service it before it creates a bad part.
And here is the kicker for me. They pulled this whole transformation off. The planning, the custom building, the software integration in just 12 months.
1 year. That is an absolute sprint in the manufacturing world.
How does that timeline even work?
From receiving the order to the FAT, that's the factory acceptance test at D&Y's facility, and then finally the SAT, the site acceptance test at the client's factory. 12 months to completely rewrite the DNA of a company.
Okay, let's get to the part everyone is waiting for. The after state. We teased the numbers at the beginning, but now that we understand the tech, the custom winders, the AOI, the MES, I want to really contextualize what these numbers mean.
Let's look at cycle time first. We went from 300 seconds down to 35 seconds.
That is almost 10 times faster. That's incredible.
It means a finished, tested, perfect motor rolls off the line every 35 seconds. Bam, bam, bam. It turns the factory into a printing press for motors.
And the yield, 30% to 99%.
That is the difference between a failing business and a market leader.
Yeah.
I mean, think about the profitability swing. You aren't throwing away 70% of your materials. You aren't paying people to rework broken parts. You are effectively printing money.
Now let's talk about the labor reduction, because this is always the controversial part of automation. They went from 30 people to 5.
Yes. A 70+% reduction in headcount on that specific line.
On the surface, that sounds like robots taking jobs.
It is a reduction, certainly. But we have to look at the quality of the jobs. Those 30 people were doing repetitive, physically taxing, error-prone work. It's hard on the body, it's stressful, and frankly, it's boring.
And the 5 people remaining, what do?
They aren't turning screwdrivers. They are monitoring the MES. They are managing the robots. They have moved from blue-collar laborers to gray-collar technicians.
So it's an upskilling of the workforce.
Exactly. And the company has stated that because their capacity boosted by 150%, they can now take on massive orders. They needed more people in shipping, logistics, and quality assurance. So those displaced workers were redeployed.
That makes perfect sense. If you are making 1.5 million motors instead of a few thousand, you need a lot more people to put them in boxes and ship them out.
Precisely. Automation doesn't always mean firing everyone. Often it means moving people to higher value tasks because the volume of business just explodes.
The client was apparently happy enough with this result to give this project a nickname, Taiwan #1.
That is a huge badge of honor in the region. It signifies that this isn't just good enough manufacturing. This is world-class. They called it Asia's first e-bike fully automated production line.
It's a shift in identity for them then.
It is. They aren't just a supplier anymore. They're a technology leader. They successfully integrated 8 distinct processes, winding, welding, testing, assembly, into one seamless flow. That is a massive engineering flex.
So, stepping back a bit, what is the big takeaway here? Most of our listeners aren't running motor factories Why should they care about the difference between 300 seconds and 35 seconds?
The takeaway is about the changing definition of quality. We used to think quality meant handcrafted. The image of the old Swiss watchmaker filing a gear by
Yeah.
candlelight.
Right, artisanal. We pay extra for artisanal coffee and artisanal bread.
But in the modern world, especially with electrification and high-tech hardware, artisanal is actually a liability. You don't want a unique motor. You want an identical motor.
You want consistency.
Consistency is the new quality.
Yeah.
If I buy an e-bike, I want to know for a fact that the winding is perfect. I don't want my safety or my battery range to depend on whether the worker who built my motor had a fight with their spouse that morning.
That's a great point. Automation guarantees that every single customer gets the best possible version of the product.
Exactly.
Yeah.
So machine-made is actually the premium standard now. It marks the shift from semi-auto, where the human is the bottleneck and the source of variation,
Right.
to fully auto, where the data drives the pace and the quality is locked in.
And there was one more detail in the notes about flexibility. Even though it's fully automated, it's not rigid.
That's the final key point.
Yeah.
Because you only need 5 people to run the line, you have incredible elasticity.
Elasticity.
Imagine demand spikes. Maybe it's Christmas season. In the old days, you'd have to hire and train 30 new people, which takes months.
Yeah.
Now, you just run the robots for an extra shift.
You just flip the switch.
And if demand dips, you don't have to do mass layoffs of 30 people. You just dial back the machine hours. It gives the business incredible resilience to market fluctuations.
It sounds like D&Y didn't just fix a production line, they built a survival mechanism for this company.
They built a growth engine. They took all the friction out of the system.
It's a compelling story because it shows how hidden manufacturing really is. We see the bike zooming past us, but we don't see the 35-second robotic dance that made it possible.
And we definitely don't see the 30% failure rate that used to exist.
Which brings me to a final thought for everyone listening. We talked about e-bikes today, but look around your house. Look at your blender, your vacuum cleaner, the fuel pump in your car.
How many of them were made on a semi-automatic line with a high failure rate that, you're paying for?
Exactly. How many industries are still stuck in that before state? And what happens to the price and quality of our goods when the D&Y approach finally hits construction or food processing or healthcare devices?
The inefficiencies we accept as normal today are going to look absolutely ridiculous in 10 years. The standard has been raised.
I think you're right. The invisible revolution is just getting started. So next time you hop on an e-bike and zip up a hill without breaking a sweat, spare a thought for the robots that wound those coils. Thanks for diving in with us.
See you next time.